Hey, welcome. We'll go through this worksheet excuse me, in a series of videos. I've got a limited amount of time this morning, so I think I'll get through the first couple of pages and see how we're doing. Find each of the following limits, show all work. Do not remove the limit notation until you actually take the limit. Apparently that's going to need to be done in C and D. Number one, the first thing we're going to try to do is direct substitution on any limit problem. So I'm going to get 3 times 1 squared minus 2 times 1 plus 5. And I suspect maybe the only way we could miss this now is if we multiply 3 times 1 before we squared. But 1 squared 1 times 3, 3, minus 2 plus 5, that's 3 plus 5, 8, minus 2, just plain old 6. And nothing to that. Shouldn't be any problem on the first problem on the test. Number 2. Again, going to try direct substitution. In fact, I know that's going to work because I know what the graph of a cubic polynomial looks like. It is continuous. So I'm going to put in negative 2. I get negative 2 times negative 2 to the third plus 2 times negative 2 to the second minus negative 2 plus 3. Might as well change this to plus positive here. Now let's see, I get negative 2 times negative 8 plus 2 times 4, plus I think I'll just combine these, plus 5, or 16 plus 8 plus 5, 24 and 5, 29. Okay, so those are the basic simple ones where we can just use direct substitution. C, there's a chance we can't here. Now, when I direct substitute 0 in for the x in the denominator, that's not the whole problem, but that's a little bit of a problem. If the numerator would not become 0, let's say it was 3, and I had 3 over 0, then the limit would not exist. Or if it was negative 7 over 0, the limit does not exist. But if the numerator is 0, 0 over 0, I've got some work to do. Well, I put in 0, I get 3 minus 0, 3 squared, 9, minus 9, and that is 0 on 0. So I have to keep limit in here for a bit. Limit as x approaches 0. If I FOIL this, I'm going to get 3 times 3, 9. I'm going to get 3 times minus x, and minus x times 3 from minus 6x's, and I'm going to get minus x times minus x plus x squared with a minus 9 all over x. And we're just hoping good things can happen. Our number one offender in this problem is this. So I'd like to be able to cancel that x. Limit as x approaches 0. 9's cancel. I get negative 6x plus x squared, or perhaps x times negative 6 plus x, all on x. And now I can cancel that offender, and I can direct substitute, and I get equals negative 6 plus 0, or negative 6. Okay. And sometimes when we get 0 on 0, it really almost helps our algebra the rest of the way. It'll give us some hints on what we can do. When I put in 3 halves, clearly in the denominator, I get 2 times 3 halves, 3 minus 3, 0. So I'm going to take a look at the numerator off to the side here. If I get 8 times 3 halves squared, that's 8 times 9 fourths minus 26 times 3 halves plus 21. I think I know where this is probably headed, but let's see. 8 divided by 4 times 9. 8 divided by 4, 2 times 9, 18. 26 divided by 2, 13 times 3 minus 39 plus 21. And sure enough, 18 and 21 is 39 minus 39, 0 on 0. Now, you say, well, now I got to go back and figure out how to factor this. No, I think I just figured out how to factor it. Limit as x approaches 3 halves. If 3 halves is a 0 of this, then 2x minus 3 should be a factor. In other words, 2x minus 3 made this 0. What what linear factor am I going to get up here that makes this 0? I could use x minus 3 halves to factor out, but I believe I can get away with 2x minus 3. Let's see how this works. 2x minus 3. Well, 2x times this term would have to be 8x squared. So if this is going to work, this must be 4x. And negative 3 times this term would have to be positive 21. So negative 3 times negative 7. Could it be that easy? Let's FOIL and check. Of course, we've got our 8x squared. I get negative 14x's minus 12x's, negative 26x, and sure enough, it works. All on 2x minus 3. 2x minus 3 cancels, and now I'm ready to direct substitute. I get 4 times 3 halves minus 7. 4 divided by 2, 2. Times 3, 6 minus 7, or the limit is negative 1. Okay, so not huge challenges on the first page, but they could be facing us soon. Okay, graph the function. Find the points, if any, at which the function is not continuous, and state what type of discontinuity exists there. List all vertical and horizontal asymptotes and all x and y intercepts. So there's a lot for us to do, but the good news is all of the answer spaces are provided for you, so we shouldn't be forgetting anything. So I'm going to take a look at this denominator and see if this can factor. Factors of negative 8 that add up to 4 factors of negative 8 that add up to 2 are plus 4, then minus 2. Quick FOIL check. X squared minus 2x plus 4x, that's plus 2x minus 8. Okay, so what do we learn with this? We learned that we don't have any holes in the graph, which we're kind of coming to expect in calculus, but we do have some asymptotes. I always say there's 3 zero tests that we do. First off, I'm going to check when the numerator equals 0. That would be x plus 2 equals 0. That means x equals 2. Well, what happens when the numerator equals 0? When the numerator equals 0, provided the denominator is not 0 there, that's when the function equals 0. 0 on 6. 0, 0 on negative 11, 0, 0 on anything 0 except 0. And since I don't have an x plus 2 factor on here, this is really the point, leads us to the point 2, that's negative 2. Negative 2, 0. So negative 2, 0 is on our graph. And I like to say, well, that's a 0 of the function, but important thing is that is not just a 0, that is the only 0. So the analogy I'm using for that is, if this was street level, and here's all the people hanging out up here, and here's all our mole men hanging down here, the only way our mole men can get up is through this point right here. That's just our manhole cover. We can come up through the sewer system. The only way that people can get down here is through there. In other words, this isn't just a 0, it is the only 0. It's the only access we have through the x-axis. All right, let's go denominator equals 0. The denominator equals 0 when x equals negative 4 and 2. But denominators can't equal 0, and provided we don't have a hole in the graph, in other words, match a 0 in the numerator at negative 4 and 2, those are vertical asymptotes. X cannot equal negative 4. And x cannot equal 2. The next thing I do is I check what happens when x equals 0. And the only reason I do that is because that's just a really, really simple t-chart point. I may t-chart some more over here, but when I put 0 in for x, I get 0, 0, 0. I get 2 on negative 8. Put in 0 for x, I get 2 on negative 8, negative 1/4. So 0 is right here. And if I understand the mole man, when this curve comes from here to here, it cannot pass back up. There's no avenue through the x-axis. I believe this curve is going to get sucked down along this asymptote, but let's see what happens after that. Next, I do what I'm referring to as the big X test. And the big X test is just basically consider our limits as we approach infinity. As we approach infinity, this x plus 2, let's just say a billion. A billion plus 2 is basically a billion. And you're going to say, well, 2 times a billion is big, but nothing compared to a billion times a billion. So really, this function wants to look like x on x squared. But x on x squared wants to look like 1 on x. And as x gets huge, 1 divided by a huge number approaches 0. So we're going to have asymptote. This leads us to conclude that we're going to have asymptote of y equals 0. Y is going to become close to that. And it doesn't matter whether we put positive or negative in here. Negative values, I get a big negative over a way bigger positive. So let's listen to that just for a second. A negative value, I get a big negative over a way, way bigger positive. So it's going to approach 0, but it's going to approach 0 from the negative side, because it's negative divided by positive. Big positive, I get positive divided by positive squared. So it's going to approach 0 to the right, but positive divided by positive is positive. We're going to be on the positive side there. So that's helpful for us. That gives us an idea how our curve exists. So our x-intercepts, the only x-intercept I have is 2, or negative 2, excuse me. I'm going to put negative 2, 0. Y-intercept, the only y-intercept I have is 0, negative 1/4. Of course, we couldn't have more than one y-intercept. This would not be a function. Okay, vertical asymptotes, got them. X equals 2, x equals negative 4. Horizontal asymptote, got it. Y equals 0. Non-continuous, I've got those too. Now, I haven't filled in the graph. I'll do that in just a moment. By non-continuous, if I understand the asymptotal behavior here, by non-continuous, the places where I have to pick up the pen are when I step over the asymptotes. So those are non-continuous. That is at x equals negative 4 and 2, and those are infinite. Discontinuities. Okay. What's left is just to fill in the curve. Now, depending on how exactly we want our curve, I might want to add a t-point or a t-chart point, maybe over here at negative 5. I might want to do that to figure out. See, I know what this curve looks like. I cannot cross. This is a mole man down here. There is no avenue to get up in with the regular people. So I know this curve is going to act like that. I just don't know how tight it gets, and depending on how much we want that, I might put in negative 5 into my function t-chart and get a target point. But I'm just going to say that is going to be enough for the purposes of this test. We got a lot on our plate. If we can get that general shape, we certainly have enough information to answer all the questions. Okay, how about the curve inside of here? Well, I know I'm going through this point. The only question is, might I be bouncing back down when I touch that? I know I can't come up here and go back down. Mole men. I can't cross again. It's my only avenue through that manhole cover. But because x plus 2 is gives just a single 0 of negative 2, it's going to pass through this point as though it were a line. Therefore, our graph inside of here is going to look like this. Again, you might want to put some additional points. You might want to choose, depending on how accurate the curve should be. What I don't know is over here where I'm going to be. Oh, wait a minute. Yes, I do. Because I went ahead and figured out what was going to happen eventually. We were going to do this. So we must stay up here in zone A, approaching this asymptote. It's just, am I here? Am I tighter than that? How much information do I need? Maybe I should, if I needed an accurate graph, come over and try out 3. And just so I can get a target point in here, or maybe 4. But for our purposes, we definitely have enough information to answer all of these questions, even before our graph was done. Okay, define h of -2 so that h of x, this guy, is continuous at -2. Well, h of x is most definitely not continuous at -2 right now. We've got -2 gives us a vertical asymptote at least, and that's if this doesn't factor. So we've got to figure out, like, is there a hole, is there an asymptote? So let's go ahead and put -2 into this function, and I get, so h of -2 equals -2 to the 4th plus -2 squared minus 20 on -2 plus 2. That is 16 plus 4 minus 20, sure enough, that is 0 on 0. So we have a hole, which means this guy is factorable by x plus 2. Let's go ahead and work on factoring x to the 4th plus x squared minus 20. This is quadratic on x squared. Maybe it factors into x squared. Factors of -20 that add up to 1, 5, and 4, and there's where we get our x plus 2 factor. So this becomes x plus 2 times x minus 2 times x squared plus 5, all on x plus 2, cancel, cancel. So here's the deal. This function, I haven't graphed it. I don't know exactly what it looks like. I know we do have a hole in the graph at -2, but this graph wants to look like, I'm going to define it as f of x. For the most part, this graph looks exactly like, in fact, I might not even need piecewise for this, x minus 2 times x squared plus 5. Started thinking this was piecewise. It looks like that with the exception of the hole. That has basically put the hole back in play, because I no longer have this x plus 2 in the denominator. Therefore, we could redefine this as f of x equals, let's FOIL this, I get an x cubed, I get a minus 2x squared, I get a plus 5x in the FOILing process, and I get a minus 10. Okay? All right, and number 4. Let f of x equal 4x minus x squared. Find c on the interval from 2 to 4 where f of c equals 2. Well, if f of c equals 2, f of c is also clearly 4c minus c squared, and if both of these equal f of c, I'm just trying to find when 4c minus c squared equals 2. And that's just quadratic equation. 0 equals add c squared, subtract 4c, joins a plus 2 on this side. Factors of 2 that add up to -4, we don't have any. If only we had some formula to handle quadratics when they don't factor. Opposite of b, plus or minus square root b squared minus 4 times a1 times c2, all on 2 times a, 2 times 1. So I get 4 plus or minus root 16 minus 8, 8 on 2, or 4 plus or minus, this is 4 times 2, square root of 4, 2, root 2 on 2. I've got 4 apples and 2 oranges. Divided by 2, I get 2 apples and an orange. So find c, c equals, and there's our solution. So I need to wrap up at this point. There will be more of these videos to come for this review. Thank you very much.